Hello, in this video I'm going to be going over hybridization. And hybridization pertains to the molecular geometry and orbitals of electrons. And what it's looking at is a hybrid is where you take two orbitals and you mesh them together and you form a hybrid orbital. It's like a hybrid car. You have electric power and gas power both coming in to form this hybrid car that uses two different power sources. Same with orbitals. You have S, P, D, and F orbitals. Remember, the S is kind of a sphere shape, whereas the P has three little bow ties that look like this. One's coming up and down, one's sideways, and one's out at you and inward. And then you have the D orbital, which is a little kind of like a flower, and you have four of the flowers, and then the fifth one is this little bow tie going through a donut type deal. So S, P, D, and an F orbital we don't really talk about too much because it gets a little more complicated. So we'll stick with S, P, and D. For the hybridizations that we're going to be talking about is you could have sp3 is a common one. Let me just write these down. So we have sp3. That's just if you have single bonds. So you have one s orbital and three p orbitals that are all kind of meshing, overlapping to form an sp3 hybridized orbital. And then you have sp2. This is one double bond. If you have a double bond, you're going to see sp2 hybridization. Sp is either one triple bond or two double bonds. That's going to be sp hybridization. Then, when you get to expanding the octet, breaking the octet rule, you could have spd or sp3d or sp3d2, and there are more beyond that, but those are all that we're going to focus on this in this class. Alright, going back to this sheet again, what we have is electron groups. So what does that mean? It's talking about groups of electrons that are attached to this center atom. So here we have 2 electron groups, and it's not talking about two atoms. So two atom molecule doesn't really pertain to. It has to have a central atom and at least two outer atoms. So that's going to be sp hybridized, meaning it has either two double bonds or one triple bond in there to make that linear 180 bond angle. Then if you have 1, 2, 3 electron groups, 3 terminal atoms, or in this case 2 terminal atoms and 1 lone pair, 3 electron groups, it's going to be sp2 hybridized, meaning there is at least one double bond in these shapes to make that shape. And moving on, we have 1, 2, 3, 4 electron groups, 1, 2, 3 terminal atoms, 1 lone pair, 4 electron groups. It's going to be sp3, which means you just have single bonds. And then 1, 2, 3, 4, 5, once we get into the expanded octet, now we have 5 electron groups. Here's 4 terminal atoms, 1 lone pair, 5 electron groups. This is going to be sp3d hybridized. And 6 electron groups, like octahedral is 1, 2, 3, 4, 5, 6. That's going to be sp3d2. And another way of thinking about this hybridization is to think about electron groups. So you see a molecule, you count how many terminal atoms and lone pairs there are, and let's say there's 2, then S accounts for 1 and P accounts for the other, that's 2. If we're saying there's 1, 2, 3 electron groups, S is 1 and this P squared is 2. So 2 P's and 1 S is 3. sp3 we have 1, 2, 3, 4. We have 3 P's, 1 S, that's 4. sp3d, we have 1, 2, 3, 4, 5. Here's 3, 4, and 5. And sp3d2, this guy is 6. 1, 2, 3, 4, 5, 6. So we have 3, 4, 5, 6. Different ways of looking at it. Alright, doing some examples. Let's look at this. Start with the simpler ones. We have SO2. It's better written right here. It's 1, 2 terminal atoms and 1 lone pair. That is 3 functional groups. So in order to be 3, it could be SP. Well, that's 1, 2. It needs to have a third one. So this one's SP2, which makes sense because SP2 hybridized has at least one double bond. Doing another one, 1, 2, 3, 4. So it has 4 electron groups. So I'm going to go SP. That's 1, 2, 3, 4. 2 more. So here's 3 P's and 1 S. That's 4 electron groups, sp3 hybridized, and they're all single bonds, which makes sense. Doing another one, so we have CH2O. We have a 1, 2, 3, just 3 electron groups. So this guy has to be sp2, 2 P's and 1 S, 3 electron groups. And sp2 means there's at least one double bond, and there in fact is at least one double bond. Here we got bent, 1, 2, 3, 4 electron groups, so this is sp3, 3 and 4. And there's no double bond, there's just single bonds. Here's one, 1, 2 electron groups. You have just 1, 2 electron groups, that's sp means there needs to be at least one triple bond or 2 double bonds, and there are 2 double bonds. And alright, let's get into expanded octet, just a few examples of those. Here we go. We have 1, 2, 3, 4, 5, 6. This guy's square planar and it's 6 electron groups. So we have sp3, that's 3, 4, 5, 6. That's sp3d2 hybridized. And then we have 1, 2 terminal atoms with then 1, 2, 3 lone pairs, so that's a total of 5. This guy's linear. 5 electron groups is sp3, that's 3, 4, and 5d. sp3d hybridized. And this one, 1, 2, 3, 4, 5 electron groups. This one also is sp3d. And this one, SEI6, 1, 2, 3, 4, 5, 6 electron groups. It's sp3 D2, 3, 4, 5, 6. And that is hybridization.